Okay, everybody, we're going to talk about in this section for the z-test for population proportion. This is the section 8.2 in the textbook. And before we talk about z-test for population proportion, let's review a few concepts that we did before. So notation P represents the population proportion. P hat represents the sample proportion. One is for population, one is for sample. Here, p hat can be used as point estimate of the population proportion p, right? This is what we talked about in chapter 7 in confidence interval. Please do not confuse this p with p-value because they are different. So p is only for population proportion, not the p-value that we've been doing a lot in p-value method. All right, so in this section, we'll be just focusing on hypothesis testing. So hypothesis testing to test a certain claim, and this claim is about population proportion. A lot of times, when you are testing a claim about proportion, you will be seeing some percentage in the question itself. So if you see the percentage, you know this is about population proportion. All right, so 3 possible sets of hypothesis testing for population proportion. You can have p is less than p sub 0, p is greater than p sub 0. These 2 sets are, one is for left-sided, left-tailed. This is right-tailed. In general, this is called one-tailed test, right? These 2 are one-tailed tests. While the last one, according to the alternative hypothesis, p is different from p sub 0, so this is a two-tailed test. The type of test will be helpful for us to determine the p-value. Notice that in the null hypothesis, it's always p equals to a value. Okay. So it doesn't change for your null hypothesis. In order to test a claim about a population proportion p, we use z-test. When it comes to calculator, we do one proportion z-test. This z-test is different from the z-test for mean. I do want to emphasize that. Even though it's called z-test, but it's z-test. It's z-test for population proportion p. Requirements. The requirements are usually met, so this is not something you should worry about. And here is just some information for you. Sample must be a simple random sample. Condition for the binomial distributions are satisfied. The reason is if the item is of interest or the item is not of interest, only two outcomes. There are at least 5 successes and at least 5 failures. These are typically met, so not too much for you to be concerned. Since we're using z-test, we should have a test stats. So test stats here would be z. This would be something you need to put on your formula sheet when it comes to the test. So z is, according to this formula, equals to p hat minus p divided by square root of pq over n. Now p hat, as we said, is sample proportion. So that's an item of interest and divided by n, that is p hat. And then p in this formula is the p that appeared in null hypothesis. Okay. So basically, it is the same p here. P equals to p sub 0. So p is p sub 0. And q, okay, q is always related to the p, right? In the sense that q equals 1 minus p. These are all the old concepts we've talked about before. So that's for test stat. And once you have the test stat, we can look for the p-value. Let's see, this is the general flow chart, right? The flow, the 5 steps you carry out the z-test for population proportion. Step 1 is stating the hypothesis, null and alternative, and the type of test is a one-tailed or two-tailed, left-tailed or right-tailed, significance level, which is alpha. Step 2, compute the PZ test stat z value from the sample. So z is p hat minus p over pq over n. Step 3 finds the p-value. Now, since we are doing the z, okay, because we are using z value for the test stat. So the p-value could be obtained either by using normal curve or using calculator function. You can do either one of those during the test, but you need to know how to do these manually, okay? Especially use normal curve for p-value. Step 4, once you get the p-value, we can make the decision regarding the null. Just compare the p-value with the alpha. If p is low, null must go. If p is high, null will fly. Step 5, summarize the results using the template as established in section 8.1. So these 5 steps are the same as we did previously. Only thing different is the test stat is different, and hypothesis will be different, right? Because it's about P, population proportion. Alrighty, let's look at one question for illustration. This question is also on your handout. So suppose we take a sample of 300 women and find that 228 of them have ever dyed their hair. Using alpha equals 0.01, test to determine whether more than 75% of all women have ever dyed their hair. Once you see percentage in the claim, right, this is about proportion. So you should have P in your hypothesis. Now the hypothesis is to determine whether more than 75%. So P would be greater than 75%, which is 0.75, and alternative hypothesis. Null hypothesis would just be P equal to 0.75. Because of this not a greater than sign, this is going to be a right-tailed test. Other information you can know is 300 is going to be sample size n. 228 are the number of women have ever dyed their hair, which is item of interest in this particular case. So that is x. And then 75% has been used in the hypothesis. So this is the hypothesis, and let's use both methods to find p-value. Okay, one is using normal curve, one is using the calculator. So let's see. If we only use normal curve, if I want to use normal curve, okay, we need to first calculate the z. So z is the test stat here. So z would be p hat minus p divided by pq over n. P hat will be x over n. Right, sample proportion, and minus p divided by pq over n. In this case, x would be 228. That's your x. N would be 300 as we have seen. And the p will just be 0.75. So we'll plug these information in, divide by p, which is 0.75. Q would be 1 minus p, which is 0.25. So 0.25 and divide by n, which is 300. So you can use calculator for this. Make sure you can get the right answer. You can add a parentheses here, and parentheses here, and parentheses here to make sure the calculator will be doing the right operation. So the z would come up as 0.40. Once you got the 0.40, okay, that's z. We're going to put this on to the normal curve, as we've been doing a lot. So normal curve, and z is for standard normal variable. Therefore, the mean is going to be 0, as we said numerous times. So here's going to be 0. And 0.40 is to the right of 0. And you separate the 0.40 from everything else, you get this part. We shade the right tail because this test here is a right tail test. So right tail needs to be shaded, right? And then you just calculate this area, which is the right tail, by using normal CDF. So it'd be normal CDF. Lower limit will be 0.4, upper limit could be 100. And by using normal CDF, you can get this area, which is 0.345. That is the p-value. Okay, so that's how you find the p-value by using normal curve. We can also find the p-value just by using the calculator function. Here, you should go stats, and then move on to the tests, and then you look for z-test. However, it's not the regular z-test, it's the one proportion z-test. Kind of consistent to what we did previously, one proportion z interval. So here's one proportion z-test. And then since we are given with the stats, so you just choose stats. All right, so you guys go ahead and work this on your calculator, and let's wait for the output. Eventually, in the calculator, you should have some output that's related to the z, okay, which is 0.4, and a p-value, which is 0.3446. Okay. Now, once you got this p-value, we're going to compare this p-value with alpha, right? Make sure you include this, which is your test stat, and this p-value in your answer. So p-value here is greater than alpha. So therefore, we should fail to reject null hypothesis. Because p-value is high, p is high, null will fly. So fail to reject null hypothesis. We summarize this as there is not sufficient evidence, fail to conclude or to claim or to state that at alpha equals to equals to 0.01. Okay, you guys know, just write it out. 0.01. That fail to reject is the same as fail to accept alternative. So the meaning of alternative, right? That more than 75% of all women have ever dyed their hair. Okay? So the same procedure as we did before, right? Next question is example 2. In a sample of 200 middle school students, 88 were able to spell the word license correctly. Using alpha equals 0.05 test to determine whether fewer than half of all students can correctly spell the word. Okay. All right, so what we see is we're trying to test to determine whether fewer than half of all students correctly spell the word. So because they're talking about fewer than half of all students, alternative will be fewer, so less than 1/2. This is about a percentage, right? So P will be less than 1/2, which is the same as 0.5, because 1/2 is 0.5. Null hypothesis would just be P equals to 1/2, okay, which is 0.5. Okay, so this is a left tail test because of this less than sign, and 1/2 can be converted as 0.5 as we just mentioned. And for simplicity, let's use calculator again to calculate the z, the test stat, as well as the p-value. I'll let you guys do that on your own, so you can get z stat as negative 1.697. So if you use the calculator, you get a z stat as negative 1.69, and the p-value can also be obtained as 0.0448 by using the calculator. So here p-value is actually less than the alpha, okay, because alpha is given as 0.05. By the way, 88 is going to be your x, and 200 is going to be your n if you're using calculator. So since p-value is less than the alpha, we should be rejecting null hypothesis, okay? Null is low, p is low, null must go. Therefore, we say there is sufficient evidence to conclude that fewer than half of all students correctly spelled license, which is the meaning of alternative hypothesis. Okay, it'll be useful if you can include the p-value towards the end as well. All right, that's all. Thank you.